Hello everybody, I'm here with a very simple example of how we can use the relative motion analysis as it relates to velocity analysis. So this is a very simple example, and I have also the same problem solved using the shortcut, the instantaneous center. And I think I've done also in the same problem acceleration analysis, which you will see later on in this series of videos that I'm going to give you the link. Anyways, so here, obviously the motion of this bar, which is connected to rollers at each end, right, is combination of translation and rotation. Okay, so at this instance, so remember, this is only good, the analysis that we do is only good for one instance. So at this instant, we are told, or we are given that velocity of A is 6 meters per second downward, like that, as shown. So we want to find velocity of B at this instant. Now, B has no choice but to move what? Horizontally, because it's confined to move like that. And also find omega. And notice that because velocity of A is downward and velocity of B is to the right, omega has no choice but to rotate, or the bar has no choice but to rotate counterclockwise. So that's what we are trying to find. Okay, and we want to apply what? The relative motion analysis. You guys remember in the previous video that, say, if you want to find velocity of B, that's equal to velocity of A plus VB slash A. So let me show you this part. VB slash A means what, guys? In the previous video, I talked about this. This is the rotation part of the motion. That means find velocity of B as if A is fixed. So we know A is not fixed, but if A was fixed, so if I draw this bar for you at this instant, and by the way, it's clear that this guy is, at this instant, is 3 meters, because the length of the bar is what? 5 meters, right? 3, 4, 5. Okay, if A was fixed, right? Imagine if A was fixed, and this bar was rotating which way? Counterclockwise. What would be velocity of B? Velocity of B would be like that. B relative to A, of course. And that would be 90 degrees to what? To the radius. The length of this bar is what? 5 meters. So remember, A is fixed, and this is point B. So VB slash A becomes R omega. Let me actually clean this up for you. VB slash A becomes R omega. R is 5, and omega we don't know. But look at the slope of this guy. Since the slope of this guy is 4 over 3, one that is perpendicular to it has a slope of 3 to 4. And that's very important. Remember, I'm not doing this problem vectorially for you, not in terms of the cross product, because VB slash A could be also done vectorially by doing omega cross R. But I don't think it's a good idea to use I, J, K for these type of simple problems. Okay, let's go ahead and try to fill into this equation here. So what do we know about velocity of B? Of course, we don't know what it is, but we know it's moving horizontally. So what I'm going to do, instead of doing the vector approach, I put the magnitude here, which I don't know what it is for velocity of B. Then I put the direction of it, as you see here. What about velocity of A? Velocity of A, we know everything about velocity of A, 6 meters per second going downward. What about VB slash A? VB slash A is right here, 5 omega. At what direction? Like that, with a slope of 3 over 4. So now, I think I paused this by mistake, guys, here, sorry. So all I did, if I missed anything, I'm just plugging into this equation, right? So velocity of A is 6 going down, velocity of B relative to A is 5 omega, right? At that direction. So now, all we have to do is to equate the horizontal and vertical components. So I'm going to actually start with the vertical components, and I'll take this to be, for example, positive. So what I have, the left-hand side doesn't have any y component, right? Because it's horizontal only. This would be a 6, and this would be a negative 5 omega. By the way, it doesn't matter if you take downward positive or upward positive. It doesn't make any difference. 5 omega, what's the y component of this guy? Y component of this guy becomes 5 omega times what? 3/5, right? So 5 omega times 3/5. And look, if you go ahead and solve for omega, omega becomes 2 radians per second. That was easy, right? So at this instant, this bar is rotating at 2 radians per second counterclockwise. Then come back to the same equation here, and this time equate the horizontal components. Let's take that to be positive. So we have VB equal, this guy doesn't have any x component, so it's 0 or horizontal component. What's the x component of our second term? It's 5 omega times 4/5, right? So 5 omega times 4/5. And you already know what omega is. Omega is 2 radians per second. Plug it in there, and you get velocity of B equal 8 meters per second. Which way? Obviously horizontal. Okay, so I hope this made sense to you, and hopefully I come back with more examples. As always, thanks for watching and listening, and stay safe and well. Thank you.